Swayam Prabha. Digital India. Educated India.
Before we go on to fitting the model for our more realistic examples, let us look at this analytical solution for the cumulative sales as well as sales rate, nothing but total adopters and the adoption rate and time of peak sales or the inflection point. Yeah, so time of peak sales will coincide with the inflection point. So these are the different terminologies for same thing. Just make a note. So in Boss model, we written that AR is nothing but dA by dt, that is change in the adopters, which is A into P plus C into I into P into A by N. Since we set we will set C into I is equal to Q, and we already know that P is nothing but N minus A. We can rewrite this as A into N minus A plus Q into N minus A into A by N. It can be further rewritten as P plus Q into A by N into N minus A. Again note A is equal to 0 at t equal to 0, rather at t is equal to 0. There should be subscript t for all A and P has a subscript t in it. Yeah. We started off with similar dA by dt equation in the previous case, and then we had a lengthy derivation. I will take the liberty to skip that part and directly jump to solving one. Yeah, A small, oh sorry, it should be small p, I am sorry, small p, sorry. Solving one, we can get adopters at time t as n into 1 minus e power minus of p plus q into t divided by 1 plus q by p into e power minus p plus q into t. I can call it equation 2. Based on this, we can get our time of peak adoption in a similar fashion, or your t star what you saw earlier is minus 1 by p plus q to ln of p by q. So this t star for the cases when p is greater than q becomes negative, right. So that means t is negative, so that is why you are having a peak at t equal to 0, and the number of adopters at t star, that is AR at t star, is equal to 1 by 4 q into p plus q the whole square. This can be derived in a similar fashion as we saw last class. It is just little time consuming, but not that difficult. You can solve that because it is just one variable, you just have to integrate it. Yeah, to our Bas model. So, people have been using the Bas diffusion model for quite some time. The various studies that has been reported to look at the diffusion speed across various countries and products. For example, that paper, the link is given. So, they are given some best guesses of P's for various type of products. The P's and Q's are going to differ based on whether it is a FMCG good, a fast moving consumer goods, or is a durable goods, etc. For example, a baseline case of US consumer durable is as in 76 was given as the base case, and based on that people are given various estimates for P's. Similarly, we have various estimates for Q's. As you can see, even in the base case, the best case for P is 0.02, while best guess for Q is 0.47, where word of mouth is clearly dominating here as compared to over advertising effects. Similarly, things can be compared across, like so non-durable goods, for example, let us see, there are things like industrial goods which are quite comparable, it's 1.149, it's 1.05, things are somewhat comparable in case of some of the items as opposed to the other ones where it is quite far apart. So, with that, let us move on and figure out how we are going to do for the same example we will take up what we did last class. So, suppose we are given the sales rate, again we have a nice hump shaped pattern of the sales rate or the adoption rate. Now, how will we fit our parameters or estimate our parameters for the Bas model, which in this case happens to be P, Q and N. When it was only Q and N, that is C into I and N, we use couple of ways that we solved it. Now, we have another factor called as P. So, let us see how we can do that. Let us take the equation as it is. Let us take what is happening to our say AR. Instead, let us just put AR at time t plus 1 is P plus Q by N into AT into N minus AT, which can be further expanded as AR at time t plus 1 is P into N plus Q minus P into AT minus Q by N into AT squared. This particular equation is of the form y equal to A plus B x plus C x squared, right, where A is nothing but P into N, B is nothing but Q minus P and C is nothing but minus Q by N. So, now what you have is a nice polynomial already here, which we have the output variable y in terms of input x, which x and x squared, and I am just fitting a polynomial to that. So, now I need to estimate my A, B and C based on this and use it to compute my values of P, N and Q. To go one step further, we can write this, for example, Q minus P is nothing but what is Q? Let us take Q from here, which is nothing but minus C into N minus A by N. So, Q is equal to minus C into N, it is coming from equation 3 here, and P is equal to A by N, which is coming from here. Q minus P is equal to B, which comes from here. this, if you solve it, you can get c into n squared plus bn plus a equal to 0, which just implies that n is nothing but the roots of these, which is equal to minus b plus or minus root of. So, total population is nothing but the root of this equation, and once you have n, you can use it to compute your q and p. Okay. You are not required, but just you can do it. Yeah. We changed it. Sorry. Okay. So now we can actually use this to build a regression model, which is what you guys are going to do. So you can just make note of the equation a, b and q. Again, once you get a, b and c, you can always solve these equations directly, or you can compute n and then you can solve it. So now let us go back to our slides. So now to fit a Bayes model, we estimated these parameters p, q and n we need to estimate, and we rewrote the equations for adoption rate, and we got this polynomial of this particular form. So we need to fit a polynomial of the same form. So we are going to use regression to estimate these parameters. In fact, you guys are going to do it. So use spreadsheet, do your computation. Bayes diffusion class.xls is presented there. Compute cumulative sales is already computed in the sheet, it is available in Moodle, please download it. So cumulative sales here is already computed. You compute the square of cumulative sales, and then in Excel add the data analysis tool pack, and then you click tools, data analysis, regression, and give these exact ranges that is given here. If you are using the same spreadsheet, that is what you will be giving, and click OK, and then get your a, b and c, and using the equation that we just gave you, we are going to solve for n, p and q. The same data I have already pre-computed the values for a, because we already know how to do that. You just have to include a square and use the regression, just follow the instructions, because you need both the columns. So you got, because the regression includes a column as well as a squared column. So you need to have both the columns selected so that the parameters can be fit. In Excel we pre-compute second parameters and give it. Even if you did not get a, b and c, at least using a, b and c, tell me values of n, p and q. These are values of a, b and c. What will be n, p and q? Because to simulate it, this is what we want. Any one value of n? 8002, okay. P and q? You already have n, you can directly compute p and q. P is nothing but a by n. You already have a divided by n, should give you p. It will be 0.0255 something, and q 1.1852. So now these values you can put it in your Bayes diffusion model in a Vensim file and simulate it to see where you are getting a bell shaped curve for adoption rate. You can substitute these values directly in your Vensim file right away and simulate the model. What are the Vensim model file you have for Bayes diffusion? Substitute the values of this n, p and q. Since p is less than q, we are going to get a bell shaped pattern for the adoption rate. Please check it. Input the values in Vensim of n, p and q, simulate it to get the values of adopters and adoption rate. Once you get it, I have already shown how to calculate the values for the, how to visualize, how to see the values in a table form. Once you open a table, there is a feature to copy it. You can copy and paste that data value into your Excel. Then you can compare the actual data with the simulated data. If you do that, you will get this curve. So the red curve is what I got through Vensim, which is exact same thing. You will get it in your Vensim model also. There is no randomness. You will get the exact same thing, and the blue line is a real data that we actually have. Pretty reasonable fit using the BAS model. So to get this graph, we have to copy paste the data from Vensim. You need to plug the data in Vensim, simulate it, copy the data, paste it back in Excel, and then do this. There are ways in which we can get the input data itself, the original sales data, the blue line that you see here, into Vensim, but we will I will show that later. Now to summarize this full sales example, let us look at comparison of all the fits that we have been got for the adoption rate. First so the blue line represents the actual sales data, remember that, the ragged line, and the green line was a logistic model that we first fit, remember the logarithms that we took and fit a linear regression line that is represented in this green line, which had an n value of 7900, A0 as 40 and Ci as 1.55. The logistic model, and then we did using solver, where we directly use the expression for AT and use the solver to determine the values of n, A0 and Ci, and this is the best estimate we had to minimize the means the square error. So these are the values we got. N is 8075, A0 is 89, Ci is 1.24, and the BAS model, which is shown in red. The logistic solver is in pink. This is in red color. This is the latest data that we just got, with N is 8002 and P is 0.02 and Q is 1.18. So if you see, the Ci and P are equivalent. If you can see here, the Ci and P are reducing from 1.55 to 1.24 to 1.18. At the same time, if you can observe here N is very low and A0 is also quite low compared to the second case. So it had to take a corresponding Q value so that it can try to fit a curve as close as possible. In this case, A0 is much higher, nearly 90, while the Ci or the Q is 1.24, but here we overcame the startup problem as well with a very small value for effective advertisement, and the P value again is kind of comparable to the logistic model solver scenario. So for the same, another thing you have to observe is, for the same data set we had used slightly different models and we got different results. Of course, we can just focus on logistic model solver and the BAS model here. The curves are very similar to each other and both are correct. It's not like one is better over the other. It depends on how we want to start. If there is indeed advertisement happening, then we might want to prefer BAS model. If there is no advertisement happening, we actually seeded the market by giving people freebies, or initial set of people were directly approached and they immediately bought this product, after which word of mouth predominantly took place, then you might want to represent it as a simple logistic model itself. Okay. This one green line is to illustrate that even with all these models, if you do not pay attention and be careful, you will get some plot and then you will say, okay, this is also S shaped, let me use it, but we can definitely get a better fit if we use solvers or we use exact analytical solutions to compute the values. Okay. Please remember that and observe how good a fit is and how we can improve it further based on the data given. So this BAS model can be extended similar to other diffusion model. One is to include discard and replacement purchase. Assume adopters move back to potential adopters after discarding or consuming their first purchase. They buy it and then they leave it, they abandon it. We can include it by adding additional rate which comes from adopters to the potential adopters, which is shown as a discard rate. So in this case, the equation for discard rate will be adopters divided by product lifetime. You can simulate this above scenario. When discard rate is not considered, then all the potential adopters, that is n is 100, everybody will buy the product. When there is discard rate, intuition says that some fraction will keep discarding the product every time unit. So the steady state that we will achieve will be lower than 100. What that exact value is, we can simulate it right now. You already have the BAS model, you have to open it and input these values. N is 100, P is 0.01, Q is 2.5, average product lifetime is 5. Of course, you have to include this rate in your model and define the equations for that. What is the value it is saturating? The rest of the model is same as your BAS model. So, in the BAS model you have to add this. So, do not end up just creating 2 stocks and 1 flow. There is another flow from potential adapters, which adoption rate, word of mouth, advertising effect, everything is the same. All you are doing is adding one more flow within your existing model. Okay, I did not show that part. The equation for discard rate is adopters divided by lifetime. Other extensions are also possible. For example, if you want to model repeat purchases, there is no discard, but suppose we have an adoption rate, but we want to model repeat purchases. That is, they have already purchased the product and they are already adopted, but now I am just going to keep purchasing again and again. So, here we can distinguish between sales rate and adoption rate. So, adoption is you become kind of what can I say, you adopt that brand, and sales rate is how much units are being purchased every time period. So, that can be simply modeled as, for example, adoption rate. We can create a separate variable called sales rate, and initial purchase rate will be initial sales per adopter. So, this suppose assume initial sales is 1, so initial purchase rate will be adoption rate into sales rate, sales per adopter. So, sales rate will be equal to the adoption rate only from this side. Now, for repeat purchases, I can simply add a variable called as repeat purchase rate, and we can come up with an average consumption per adopter. Suppose they are going to repeat it, how often or what quantity they repeat it in, and I can add it to the sales rate. So, my effective sales rate is nothing but the sum of repeat purchases as well as initial purchases. So, adopters are people who are actually owning the brand, and I am going to do it again and again. They are already into the product. Now, how often they are going to keep buying it again and again. Again, we can, there is no discard rate in this, remember. So, we can modify the BAS model. We can set N is 100, P is 0.01, Q is 2.5. Initial purchases 1 per unit per person, 1 unit per person, and replacement just 20% units per person per year. We can see what happens to the actual sales rate. The sales rate is at 100, will be more than 100. Eventually, it has to be little more than 100 because everybody would adopt the product. But then, how does that change is something you can try it at your home. Okay, thank you.